Network configuration. About this module. Welcome to the Network Configuration module. In this module, you'll learn about configuring and supporting various types of networks, including small office/home office, SOHO, networks. You'll learn about the technologies you can use to host networks and about the tools that you can use to configure, manage, secure, and monitor them. Finally, you'll discover the different ways that remote workers can access central resources. Learning objectives. After completing this module, you should be able to determine troubleshooting tools and apply best practices to manage and maintain a network for a scenario. Select the type of network based on a scenario about the internet connection and network features. Explain the process to install and configure hardware and software for a small office/home office, SOHO, network and keep it secure. Conclude network management software features to monitor, manage, and secure a SOHO network. Differentiate between remote access technologies and explain how to securely access and transfer files using them. Write commands to upload, modify, and download a file on an FTP server. About this lesson, common network tools. In this lesson, you'll get an introduction to some common network tools that IT support technicians use. You'll discover tools for querying, configuring, and troubleshooting networks. You'll learn about using command line tools to diagnose issues. Then, you'll explore tools and best practices for configuring wired and wireless networks. Network systems. A city at night. Networks are complex systems that require careful planning and ongoing maintenance, much like the intricate workings of a bustling city. Networks consist of various interconnected elements, such as cables, wireless signals, routers, switches, servers, and computers. These elements must work together to facilitate smooth data flow. Just as a city relies on well-designed roads and traffic systems, a network depends on well-planned architecture and protocols. Several things can go wrong on a network. Some common network issues include congestion. Too much data trying to pass through a single point can slow down the entire network. Think of a traffic jam caused by 3 lanes having to merge into one. Outages. Failures in hardware or power supply disrupt network connectivity, like road closures in a city disrupt traffic flow. Security breaches. Without proper security measures, unauthorized users can access sensitive data, much like unwelcome visitors in a city. The critical role of configuration. Proper configuration is the backbone of a reliable network. It sets the rules and guidelines for how to route and handle data packets. Incorrect configurations lead to a host of problems, from data loss and slow performance to security vulnerabilities. Think of configuring the network as setting up the traffic rules that keep a city's roadways running smoothly. Troubleshooting tools are indispensable. Troubleshooting tools are essential for network maintenance. They help identify and diagnose issues, acting as the eyes and ears for network administrators. These tools serve a role like that of emergency services by spotting and addressing problems to keep everything flowing smoothly. Effective network management is a blend of careful planning, proper configuration, and ongoing maintenance. Troubleshooting tools are invaluable in this process and help ensure that business networks like a well-run city remain reliable and secure environments for data flow. In this lesson, you'll acquire the skills needed to set up, manage, and troubleshoot networks effectively. Network installation and configuration. IBM skills build. Video transcript. Network installation and configuration. Welcome to TechNHiNet, a small technology startup. Meet Stefanos, Tenk's IT support technician. TechNHiNet is finally moving into a small office, and Stefanos has the responsibility of setting up the network. Let's learn about his overall steps. To install and configure the new network, Stefanos needs to follow 5 main steps. Prepare for installation. Install physical hardware. Install network software. Configure network software and hardware. And test the network. Stefanos' first step is to prepare for the installation. Stefanos prepares by reviewing the network requirements and choosing the hardware he needs to install. For TechniNet, he chooses the following hardware: a router to direct network traffic, a modem to connect to the internet, Ethernet cables for wired connections, a firewall device for added security. After he purchases the hardware, it's time to begin the installation. The next step is for Stefanos to install the hardware. He sets up the physical hardware, connecting Ethernet cables to the router. He then installs the modem and the firewall. Once the hardware is in place, he proceeds to install network management software to control and monitor the entire system. Now, Stefanos configures the network software and hardware. He uses a router configuration interface. To configure the router first, he sets the Wi-Fi network name and password. Next, he configures IP addressing. To set up IP addressing, he goes to the local area network, or LAN settings and turns on the Dynamic Host Configuration Protocol, or DHCP, server. Page 1 of 2. IBM Skills Build. Stefanos' next step is to configure the firewall. He accesses the firewall settings and sets the inbound and outbound port ranges. Some applications connect to the internet by using one or more outbound ports and expect an answer through one or more inbound ports. Setting the ranges allows Stefanos to manage which applications can initiate and receive network connections. With the configuration complete, it's time for Stefanos to test the network's functionality. He opens the command line interface on his computer to execute a sequence of commands that sends signals through the network to check its responsiveness and security measures. This confirms the network's performance and security. Stefanos did it. The TechniNet small office has connectivity. Now Stefanos has the network set up and working. As the office fills with employees, Stefanos will continue to monitor and manage the network and troubleshoot any issues that arise. Page 2 of 2. Command line commands for networking. As an IT support technician, you'll need to troubleshoot network problems. Network troubleshooting tools help you find your way out of a maze of related issues. These tools help you identify where the problem lies. The problem might be the device in the local network you support or somewhere along the path to a distant server. Let's explore some of these essential tools and how they work together to help you troubleshoot network issues. Many of the network troubleshooting tools that IT support technicians use start with the Command Line Interface, CLI. The Command Line Interface, CLI, is a text-based tool into which you type commands and get information back. On Windows computers, you use the command prompt and Windows PowerShell. On Mac computers, you use the terminal. And on Linux computers, you use the shell. This lesson uses the general term command prompt to refer to these programs. To use the following networking troubleshooting tools, you'll first access the command line interface. Then, you'll input the command. The typical structure of a command is the name of the troubleshooting tool followed by the information you want the tool to process. Some command line commands are common across different operating systems, others are unique and specific to each platform. Let's explore 4 common commands. Ping. Trace route. IP protocol configuration. Netstat. Ping. Imagine you're sending a postcard to a friend and waiting for a reply. The ping command works in a similar way. It sends a small packet of data to a specific address and waits for a response. If the response comes back, you know the destination is reachable. If not, there's a problem somewhere. Try it. Open a command prompt and type ping, followed by the IP address or website you want to check. For example, pingibm.com. See the results you get. The following image shows the results of a ping command run in the terminal on a Mac. Notice that each line provides valuable information. Line 2 shows the user ran a ping command, pingibm.com. Line 3 shows the ping test running on IBM.com with an IP address of 23.205.26.27. The 56 data bytes signifies that each data packet sent in the test contains 56 bytes of data. The subsequent lines represent a single ping attempt. Each line includes a sequence ID labeled ICMP_sec, a time to live, TTL, value that represents the route the data packet takes, the time in milliseconds that represents how long it takes for the ping request to travel from the computer to the website and back again, a command line interface showing the results from a ping command for IBM.com. Trace route. Trace route is like a GPS for your data packets. It shows you the exact path that data takes to reach its destination, including all the stops or hops along the way. If data is getting stuck or lost, then trace route shows you where the problem is occurring. Try it. Open a command prompt and type traceroute, or tracert on Windows, followed by the IP address or website you want to reach. For example, traceroute IBM.com. The following image shows the results of a traceroute command run in the terminal on a Mac. Notice that each line provides valuable information. Line 2 shows the user ran a traceroute command to trace the path taken by packets to reach the IBM.com domain. Line 3 shows the traceroute test running on IBM.com, with an IP address of 23.64.138.216. The 64 hops signifies that the maximum number of hops should be 64. And each data packet sent in the test contains 56 bytes of data. A command line interface showing the results from a traceroute command. Each subsequent line represents a hop in the journey. Each line includes the sequential hop numbers, from 1 to 9, which shows the order in which each point is reached. An IP address, or sometimes a domain name, which identifies that particular point in the route. Each of these addresses represents routers or servers that the data touches as it moves through the network. 3 time measurements in milliseconds, ms. These times represent how long it took for the data to reach that point and then return, measured 3 separate times for accuracy. Notice on line 4, there are 3 asterisks, ******. This typically means that the data packet did not receive a response from that particular point, possibly due to a firewall or some other security measure blocking the traceroute request. IP protocol configuration. IP protocol configuration is the go-to tool for all things related to network adapters. It shows information about each network adapter in a device. This includes the IP address, subnet mask, and default gateway. If an individual is having issues connecting to a local network, IP protocol configuration can help you identify the problem. Try it. Open a command prompt and type IP protocol configuration. The following image shows the results of an IP protocol configuration command run in Windows PowerShell. Notice that each line provides valuable information. The image displays the results from 3 separate network adapters in the device. The Ethernet adapter Ethernet represents a wired network connection. It has both IPv6 and IPv4 addresses, indicating the computer is using these protocols to communicate on the network. The IPv4 address for this adapter is 10.211.55.3, and it connects to a default gateway, which is typically a router, at 10.211.55.1. The Ethernet adapter Bluetooth network connection shows a Bluetooth connection. Currently, it's in a media disconnected state, meaning there is no active Bluetooth network connection. The Ethernet adapter vEthernet, default switch, is a virtual network connection, often used for virtual machines or containerized applications on the computer. It also has an IPv4 address, which is 172.18.240.1. A Windows PowerShell interface showing the results from an IP protocol configuration command. Netstat. Netstat stands for Network Statistics. It provides a comprehensive look at all network connections going in and out of a computer. This view is useful for identifying unauthorized connections or slowdowns in a network. Try it. Open a command prompt and type netstat. The following image shows the results of a netstat command run in the terminal on a Mac. Notice that each line provides valuable information. Line 4 displays 6 headers that describe the following information. Proto, this column identifies the protocol the connection is using. In the image, notice it is mostly TCP4, which means it's using the TCP protocol over IPv4. There is also TCP6, which indicates the newer IPv6 protocol. Receive queue and send queue, these columns represent the amount of data queued for receiving and sending, respectively. In this instance, all values are 0, meaning no data is currently queued. A command line interface showing the results from a netstat command. Local address, this column represents the IP address and port number of the local computer. All these addresses seem to originate from the same computer, as indicated by similar IP addresses like 172.20.39.198, followed by different port numbers. Foreign address, this column shows the IP address, domain name, or MAC address of the remote machine being connected to. Notice the .https at the end of each address. This suffix shows that these are secure web connections. State, this column shows the status of the connection. Established means there's an active connection. All the connections in the image are currently active and established. Scenario, using network troubleshooting tools. Explore this short troubleshooting scenario to learn how to use the command tools you just learned about. Gian is an IT support technician at Netcomps. The company relies heavily on its network for daily operations. One Monday morning, Gian receives complaints from employees on the company's messaging system. They say internet access is slow, and they're having difficulty accessing the company's internal server. Realizing the urgency, Gian starts his investigation. A man typing on a computer keyboard. Numbered divider 1. Identify the problem. First, Gian needs to understand the scope of the issue. He asks a few employees to run a simple ping command to the IBM servers, which are reliable servers to test. The results of the ping tests are inconsistent. Some packets are lost, and others take too long to return. Like cars getting stuck or delayed on certain city roads indicate a traffic problem, these inconsistent results indicate that there might be network congestion or perhaps an even bigger issue. Numbered divider 2. Check the local network. Gian uses the IP protocol configuration command on some of the affected computers to check their network settings. Everything seems normal. The computers are connected to the network and have valid IP addresses. It's as if the traffic lights and road signs in a city are working fine, but there's still a traffic jam. Numbered divider 3. Investigate the data path. To dig deeper, Gian traces the path that the data takes to reach the IBM servers. He uses the traceroute command and notices that the data packets are getting stuck at a particular point outside the company's internal network. This is like discovering that the traffic jam is occurring on a specific highway leading out of the city. Numbered divider 4. Examine network connections. Gian then uses netstat to examine the network connections on one of the affected computers. He notices some unfamiliar IP addresses connected to the machine. This is like finding some unknown vehicles parked in the company's private parking lot. Numbered divider 5. Take corrective action. With this information from his investigation, Gian contacts the company's Internet Service Provider, ISP, to discuss the traceroute findings. The ISP confirms there's an issue on their end and promises immediate action. Gian also strengthens the company's firewall settings to block the unfamiliar IP addresses, which mitigates the security risk. Within a couple of hours, the network is back to normal. Employees access the internet and internal server without any issues, and internet access is no longer slow. Gian's timely intervention and the use of essential troubleshooting tools helped solve the problem. Conclusion: networks need proper configuration and troubleshooting tools for optimal performance. Just like a city that relies on well-coordinated systems and emergency services to function well. Gian's day at Netcomps is a testament to how these tools help quickly diagnose and resolve network issues, keeping the digital lifeblood of a company flowing smoothly. Next, let's explore some tools and best practices for troubleshooting and supporting network devices. Tools and best practices for network devices. Wired networks. When it comes to setting up and maintaining a wired network, IT support technicians have a toolkit of software and commands at their disposal. These tools help in diagnosing issues, configuring settings, and ensuring that the network runs smoothly. Let's explore some of these essential tools and best practices they follow. Tools for wired networks. IT support technicians use network tools to configure, monitor, secure, and maintain wired networks. Network mapping tools. IT support technicians use the following tools to map a network. Network mapping software. Software like Nmap and SolarWinds Network Topology Mapper, NTM, send out signals to all the devices on the network and listen for their responses. This information helps the tool figure out which devices are connected and how they're linked. Network scanners. Scanners like the SolarWinds IP address tracker use complex algorithms and protocols to discover devices. They might ask, "Who's out there?" and devices respond, "I am." The scanner takes note of this information to create a detailed map. Network diagramming software. Tools like Lucidchart and Miro enable technicians to drag and drop symbols representing devices and connect them with lines. This information creates a visual representation of how devices are connected. IP address management tools. IT support technicians typically use the following to manage IP addresses. Device operating systems. Device operating systems allow an IT support technician to view or change the device's IP configuration. The technician can choose to manually assign a static IP address, along with other details like subnet mask and default gateway. Alternatively, the technician can automatically set the device to obtain an IP address if it needs to be dynamically assigned through DHCP. Network router configuration interfaces. Router configuration interfaces provide an IT support technician with centralized management of IP addresses for multiple devices. Technicians make the assignment using the Dynamic Host Configuration Protocol, DHCP, reservation feature of the router. DHCP allows them to assign specific IP addresses to devices based on their MAC addresses. Monitoring tools. IT support technicians use the following to monitor networks. Network monitoring protocols. Technicians might use protocols such as Cisco NetFlow or Simple Network Management Protocol, SNMP. NetFlow is a protocol designed to gather and examine data related to network activity. SNMP is a protocol that is used to manage and monitor devices on a network. Network monitoring tools. Network management systems and traffic analyzers are tools that use NetFlow and SNMP to monitor networks and provide a more comprehensive view of network health, performance, and security. Security tools. IT support technicians use the following to secure networks. Network configuration interfaces. Configuration tools that are built into a device are used by IT support technicians to set up or manage firewalls and other security protocols on a device. These interfaces allow technicians or network engineers to define rules and filters that control incoming and outgoing data traffic. IT support technicians use these essential tools to configure, monitor, secure, and maintain wired networks. Next, let's look at some best practices for wired networks. Best practices for wired networks. IT support technicians should consider the following best practices for wired networks. Install regular updates. Keep firmware of routers, switches, and other network devices up to date to ensure optimal performance and security. Firmware is a type of software that is embedded into hardware devices like routers and switches. It serves as an operating system for the device and is responsible for controlling its functions and behavior. IT support technicians update firmware in one of the following ways. Manually, technicians download new firmware files from a device manufacturer's website and then use the device's browser-based interface to install the updated software. Automatically, some devices support automatic firmware updates. They do this by automatically checking a special location on the manufacturer's website for new software. When an update is available, the device downloads and then installs it. Document networks. Before diving in, create a map of the network layout. Knowing how devices are connected helps you in both configuration and troubleshooting. After setup, keep detailed records of configurations, IP addresses, and changes to the network settings. This information is invaluable for future troubleshooting and audits. Validate changes. After any configuration change, use command line tools like ping and traceroute to validate that the network is functioning as expected. The ping command allows you to test the reachability of a network device. The traceroute command helps you examine the path that data takes to travel from one network device to another. These tools not only confirm that your changes haven't unintentionally disrupted connectivity, but they also provide valuable diagnostic information. For instance, ping can help you identify issues related to packet loss or high latency, and traceroute can pinpoint where a data path might be failing. Using these tools as part of a systematic validation process minimizes the risks associated with configuration changes and helps maintain a reliable network. Wireless networks. Wireless networks offer the advantage of mobility, but they present unique challenges for IT support technicians. To manage these networks effectively, technicians rely on a variety of software tools and commands. Let's explore these essential tools and the best practices for using them in a wireless network environment. Tools for wireless networks. IT support technicians use network tools to configure, monitor, and troubleshoot issues on their wireless networks. Site survey tools. IT support technicians typically use the following tools to survey a site before setting up a wireless network. Wi-Fi analyzers. Wi-Fi analyzers measure the strength of existing Wi-Fi signals in various parts of the site. This measurement helps technicians decide where to place new access points for maximum coverage and minimal overlap with existing networks. Wi-Fi analyzers also identify which channels are least congested so they can be chosen for the new network setup. IP address management tools. IT support technicians typically use similar methods to manage IP addresses as they do in wired networks. Device operating system. Device operating systems allow an IT support technician to view or change the device's IP configuration. For wireless connections, additional settings related to Wi-Fi, such as the SSID and security protocol, come into play. Some operating systems also allow prioritization of known networks, influencing which network gets assigned an IP address first when different options are available. Network router configuration interface. Router configuration interfaces provide an IT support technician centralized management of IP addresses for devices. For wireless networks, these interfaces also give IT support technicians the ability to manage the wireless spectrum. This management includes options like channel selection, frequency band, 2.4 GHz, 5 GHz, and 6 GHz, and wireless security settings, WPA2, WPA3. Troubleshooting tools. IT support technicians use the following tools for troubleshooting wireless networks. Packet sniffers, such as Wireshark capture, and analyze data packets that travel over a wireless network. These tools aid in identifying issues related to network performance, like bandwidth consumption, latency, and packet loss. On the security front, they monitor unauthorized access and detect vulnerabilities by highlighting unprotected data or suspicious patterns. Remote management software. Remote monitoring and management software provides centralized oversight and control of network devices such as routers, switches, and firewalls. They offer real-time monitoring of network performance metrics like bandwidth utilization, latency, and packet loss. The software also enables remote configuration and management of device settings, making it easier for IT support technicians to implement changes across the network without physical presence. Best practices for wireless networks. IT support technicians should consider the following best practices for wireless networks. Enable strong security. Use robust encryption methods like WPA3 and strong, unique passwords to secure the network. IT support technicians enable encryption and strong passwords typically by doing the following. Enable WPA3 encryption in the router settings and create a strong Wi-Fi network passphrase. Use strong, unique passwords for all devices and accounts, and enable multi-factor authentication where possible. Perform security audits to identify and address vulnerabilities. Divide the network into different sections and turn off any features on the router that are not needed to make it harder for hackers to get in. Install regular updates. Like in wired networks, it's important to keep firmware of routers and switches up to date to ensure optimal performance and security. It is also important to keep wireless access points up to date. IT support technicians update firmware in network devices either manually or automatically. Document networks. Wireless network documentation will have some differences to wired network documentation. Wireless network documentation should include a floor plan marking the precise locations of wireless access points, which channels are in use for each access point to avoid congestion, and the specific configuration settings for each access point, such as security protocols and SSID details. Additionally, documentation on signal coverage provides valuable insights for future network extensions or for quickly identifying and solving connectivity issues. Validate changes. Like validation on wired networks, after any configuration change on a wireless network, use command line tools like ping and traceroute to validate that the network is functioning as expected. Technicians also use site survey tools to validate that signal strength and coverage meet the requirements. Activity, using tools and best practices to manage and maintain a network. Critical thinking. Critical thinking. Welcome to your first day as an IT support technician at SOHO. In this activity, you'll be shadowing Mark, a seasoned IT support technician, as he configures, monitors, secures, and maintains the organization's wired network infrastructure that keeps this medium-sized office running smoothly. From managing IP addresses to ensuring data security, you'll help manage and maintain the wired network. Together with Mark, you'll use various tools and best practices to keep the network secure and running smoothly. Beginning the day. As you walk into the office, you find Mark sitting in the control room. He's scanning information across monitors. He explains that each morning, when he arrives, he reviews key network metrics and checks for any security concerns. This daily routine is crucial for ensuring that the wired network performs optimally and remains secure. Checking for new or unrecognized devices. As you familiarize yourself with charts and reports based on data from the network monitoring tools, Mark points out an irregularity in the bandwidth usage chart. There are spikes, which suggests that a new device might be connected to the network, possibly using up more bandwidth than expected. You launch the network scanner and initiate a scan. Managing IP addresses for the network. Based on the scan, you determine that the bandwidth issue is related to a new device. Mark tells you that the office has acquired a wireless printer. After determining the bandwidth issue is related to a new device, you shift your attention to next essential task, managing IP addresses for the network. The network router configuration interface is your next stop. As you scroll through the list of allocated and available IP addresses, Mark explains that the printers, servers, and workstations in the office have a specific range of IP addresses to make network management more streamlined. This practice helps in identifying device types based on their IP addresses and logically groups similar devices. He then asks you to allocate an appropriate IP address for this device. You turn your focus to the network router configuration interface. A series of IP ranges are neatly organized, some marked for workstations, others for servers, and a few dedicated specifically to printers. You choose an IP address that adheres to best practices and ensures efficient network management. Setting up and managing network security. After successfully allocating an IP address for the new wireless printer and ensuring it functions correctly, you and Mark turn your focus to network security. Mark opens the network configuration interface on one of the control room monitors. This built-in tool is essential for setting up and managing various security protocols, including firewalls. Mark explains that recent security audits have recommended a review and possible tightening of the existing firewall rules. He points to the interface, where you see a list of already defined rules and filters that control both incoming and outgoing data traffic. First, you both review the current rules to identify any that might be outdated or overly permissive. After some discussion, you decide to remove a few rules that are no longer needed and could potentially be exploited. Next, Mark guides you through the process of creating new, more restrictive rules. The aim of these new rules is to block unauthorized access attempts and ensure that only secure, encrypted traffic passes through certain ports. Conclusion. As the workday ends, you take a moment to reflect on the many tasks you've tackled alongside Mark. From monitoring network performance and identifying anomalies to managing IP addresses and tightening security measures, you've gained experience in what it takes to maintain a robust and efficient network. Mark emphasizes the importance of each task you've performed today. He notes that the blend of monitoring, management, and security protocols you've interacted with are the backbone of any well-functioning IT network. The day ends with the satisfaction of your having not only resolved immediate network issues but you've also taken steps to make the network more resilient for the future. As you shut down your workstation and say goodbye to Mark, you feel more confident and better equipped to tackle the challenges that lie ahead in your career as an IT support technician. Summary and looking ahead. In this lesson, you learned about the tools and best practices for configuring and maintaining networks. It's important to install regular firmware updates, document wired networks, validate changes you make, and enable strong security to ensure the network remains secure and runs smoothly. In the next lesson, you'll explore the different types of internet connections and networks you will encounter as an IT support technician. About this lesson, Internet connection types. In this lesson, you'll learn about the types of internet connections organizations and individuals use. You'll then review the different network types and how some of these take advantage of internet connections to provide their functionality. Finally, you'll review some scenarios to conclude the network type. Different types of internet connections. A woman sitting on the floor in front of a couch, typing on a laptop. The internet has gone from a novelty to a necessity for many people. Have you ever wondered how your home, university, or office connects to the internet? There are many types of internet connections for homes and offices that offer different connection speeds. IT professionals measure internet connection speeds in megabits per second, Mbps, and gigabits per second, Gbps. A bit is the smallest unit of measurement of digital information, and a megabit is 1 million bits, and a gigabit is 1 billion bits. By comparison, they measure digital storage in terms of bytes. A byte is equal to 8 bits. To download a 1 megabyte file in a second or less, an internet connection needs to transfer data at a speed of at least 8 Mbps. The following are some of the common types of internet connections available for homes and business offices. Digital Subscriber Line, DSL. This type of internet connection uses existing telephone lines to transmit data. Unlike the dial-up connections of the past, DSL allows individuals to use the phone and the internet simultaneously. Speeds generally range from 1 to 100 Mbps but are highly dependent on a user's proximity to the service provider's infrastructure. In rural areas, particularly in the United States, the significant distance between users and necessary infrastructure limits the viability of DSL. This has prompted a shift towards alternative, more modern technologies. Conversely, in many European regions, the high population density supports the continued popularity of DSL. In Africa, DSL is not only widely used but also on the rise, although the gradual introduction of competing technologies is beginning to change the landscape. Cable Internet. Cable Internet uses the same coaxial cable that delivers cable television to homes. Cable Internet provides a reliable and constant connection, as the infrastructure is less susceptible to environmental interference than some other types of connections. Speeds range from 20 Mbps to 1 Gbps. However, it's worth noting that internet speed can slow down during peak usage times, as individuals are sharing the cable with neighbors. Fiber optic. Fiber optic internet is the newest and fastest type of connection, transmitting data as light signals through glass fibers. It offers incredible speeds, ranging from 250 to 10 Gbps. It's not yet widely available, and it can be more expensive than other options. Satellite internet. For individuals and businesses in rural or remote areas, satellite internet offers a viable option. A satellite dish communicates with a geostationary satellite to provide internet access. While slower than other types of connections, usually ranging from 12 to 100 Mbps, it has the advantage of being available almost anywhere. But, it can be disrupted by weather conditions such as rainstorms, snow, and high winds. Mobile internet. Mobile internet uses the same cellular networks as smartphones. It's handy for when individuals are on the move, but it's generally not as fast as other types of connections. Speeds range from 3 Mbps to 10 Gbps depending on someone's location and the quality of the cellular network. While internet connection speeds vary, it is often the other parts of the network that limit the internet speeds in many environments. For example, Wi-Fi speeds can limit the transmission of data from the internet to a device. If a Wi-Fi router can only transmit data at 1 Gbps, it doesn't make sense to pay the extra cost for fiber that transmits data to a location at 5000 Mbps. What do you think? Critical thinking. Now that you've learned about the different types of internet connections, think about the internet connection you have. What type of internet connection are you using to take this course? Do you use different internet connections for different online activities or different locations? Evaluate your thinking. Does your answer account for the following? You might be using DSL internet if you are connected through your phone line without disrupting your telephone service. Cable internet if you have your internet delivered through the same coaxial cables that provide you with cable television, and your internet speed is relatively fast, though it might fluctuate during peak usage hours. Fiber internet if you are experiencing some of the highest speeds available. Satellite internet if you live in a rural or remote area where traditional wired connections aren't available. Mobile internet if you are often on the go, using a data plan from a cellular provider to access the internet, with speeds and reliability that can vary greatly depending on your location and quality of the network. Features and benefits of different network types. The internet is like a vast ocean of information, and networks are the vessels that help people navigate it. Just as there are different types of ships for different journeys, there are various types of networks suited to specific needs. In this lesson, you'll explore the characteristics of local area networks, LANs, wireless local area networks, WLANs, wide area networks, WANs, mobile networks. Local area network, LAN. A local area network, LAN, connects computers and devices within a limited geographical area, such as a home, office, or school. In a LAN, the router serves as the main hub that directs data traffic and connects all devices within the confined area. The router also acts as the gateway to the internet, sending online requests through a modem to your internet service provider, ISP, and back. This illustration shows a LAN in which there are 3 desktop computers connected to a router. A LAN comprising of 3 desktop computers connected to a router. In wired LANs, Ethernet cables link devices to the router, and a network switch can expand the number of connections by providing additional ports. Each device in the LAN receives a unique IP address from the router, ensuring data is sent to the correct destination. This setup offers a fast, secure, and centralized way to access the internet and share resources like printers or files. Select each tab to learn more about LANs. Features. High data transfer rates, usually ranging from 100 Mbps to 10 Gbps. Typically uses Ethernet cables for connection. Limited in size and scope. Benefits: fast and reliable for short distances. Easy to set up and manage. Ideal for sharing resources like printers or files within a single location. Best suited for locations that need high-speed data transfer within a confined space, including homes, small offices, schools. Wireless Local Area Network, WLAN. A wireless local area network, WLAN, is a LAN without the wires, using Wi-Fi technology. Just like a LAN, a WLAN facilitates the connection of devices within a limited geographical area, such as a home or office, but does so without the need for physical cables. Instead, a wireless router or wireless access point transmits data through radio waves. This setup provides the freedom of mobility within the network's range, allowing users to move around freely while staying connected. This illustration shows a wireless router that is providing connection to 2 desktop computers and a printer without the devices being connected by wires. A WLAN comprising of 3 desktop computers wired to a router and 2 laptops, and a mobile device wirelessly connected to the same router. Data transfer rates can vary and are generally lower than wired LANs. But WLANs offer the benefit of easy installation and expansion. They are particularly useful in settings where physical wiring is impractical or where user mobility is a requirement. Select each tab to learn more about WLANs. Features: provides wireless connectivity within a limited area. Data transfer rates can vary, often up to 600 Mbps. No need for physical cables. Benefits: offers mobility and flexibility within the network range. Easy to install and expand. Ideal for places where wiring is impractical. Best suited for locations where users need to move around freely within a confined space, including homes, cafes, airports, hotels. Wide Area Network, WAN. A wide area network, WAN, spans a large geographical area. It often connects PANs, LANs, and WLANs across cities, states, or even countries. Unlike LANs, WANs rely on a combination of public and private data services to connect distant locations. These services can include leased lines or the Internet itself. Because of its broad scope, data transfer rates in a WAN are generally lower than those in a LAN. This illustration shows a WAN, which is connecting a WLAN to a LAN through the Internet. A WAN comprising of a WLAN and a LAN connected via the Internet. WANs offer the advantage of connecting dispersed locations. This makes them ideal for large organizations that require communication and resource sharing across a wide area. It also enables centralized data management and broader network coverage, but usually at a higher cost and complexity than LANs. Features: can connect LANs and WLANs together. Relies on public or private data services, including the Internet. Lower data transfer rates compared to LANs. Benefits: great for connecting multiple locations over long distances. Offers broader network coverage. Suitable for large organizations with dispersed locations. Best suited for situations that require network connectivity across different geographical locations, such as large corporations, government agencies, educational institutions. Mobile network. A mobile network offers Internet connectivity over a cellular infrastructure. This provides the flexibility to access the Internet almost anywhere within the service provider's coverage area. This illustration shows cellular network tower emitting wireless signals to a laptop and a mobile phone. A mobile network comprising of a cellular tower alongside 2 laptops and a mobile device. Unlike traditional LANs and WANs, which are confined to specific locations, mobile networks provide the freedom to be online while on the move. Features include wide coverage and varying data speeds depending on the generation of the network, 3G, 4G, 5G. The main benefits are the ease of setup, requiring only a SIM card or eSIM and compatible device, and the variety of data plans to suit different needs. Select each tab to learn more mobile networks. Features: wide coverage spanning cities, states, or even countries. Varying data speeds depending on the network generation, 3G, 4G, 5G. Relies on cellular towers for transmitting and receiving data. Benefits: enables internet access on the go, providing flexibility and mobility. Easy to set up, usually requiring just a SIM card and a compatible device. Offers a variety of data plans to meet different needs. Best suited for individuals who require constant internet access while moving around. Rural or remote areas where there are limited traditional broadband options. Temporary setups like events or temporary residences. Businesses looking for a backup internet connection in case of outages. Summary and looking ahead. In this lesson, you learned about different internet connections and how to distinguish between different types of networks. You applied this knowledge by identifying the best type of network for different scenarios. The next lesson covers using internet connections and networks to create a small office/home office, SOHO, network. You'll learn how to configure wired and wireless networks for SOHO setups. About this lesson, install and configure a small office/home office, SOHO, network WAN protocols. In this lesson, you'll learn about small office/home office, SOHO, networks. You'll discover the components to include in a SOHO environment and how to configure and secure them. Finally, you'll learn some of the common issues that occur in SOHO networks. The components of a SOHO network. More and more people have the ability and desire to work from their home. So, setting up and troubleshooting a network for a SOHO is also becoming more common. Understanding the function of each component in a SOHO network makes these tasks simpler. Let's start by looking at the essential hardware components in a SOHO network. Router. The router directs local data traffic and connects to the Internet. The router acts as the central hub in your SOHO network, making sure that information reaches the right devices. The router also serves as a gateway to the Internet, connecting the local network to the Internet Service Provider, ISP. Modem. The modem translates digital data for transmission to and from the Internet. The modem is the device that connects a local network to the Internet. It takes digital data from the network and converts it into a format that can travel over the ISP's infrastructure. Usually, in SOHO networks, the modem connects directly to the router. Ethernet cables. Ethernet cables provide a physical pathway for data between devices and the router. Ethernet cables connect devices, like computers and printers, to the router. These cables come in various categories, with Cat5e and Cat6 being the most common for SOHO networks. Switch. The switch expands a SOHO network by adding more connection points. Switches provide more wired connections for devices than the router has ports for. The switch expands a network by providing additional Ethernet ports. Wireless routers. Wireless routers and access points enable devices to connect to the SOHO network without cables. Devices can use the wireless feature of devices like routers and access points to connect to the network using radio signals. This provides mobility for devices on the network and helps reduce the cost of installing network cable ports throughout the home. Wireless connections tend to be slower than Ethernet connections, however, the speed gap between the two is decreasing. Wireless extenders. Wireless extenders expand the range of a wireless network signal. For larger workspaces or workspaces that are spread over different floors, a wireless extender can help ensure that the network signal reaches everywhere work needs to get done. Wireless extenders are also known as repeaters. Installing and configuring a SOHO network. Installing and configuring the hardware for a SOHO network. Creating a reliable, functioning network involves installing and configuring these components in a way that works best for the office space. Let's follow Kareem, who just accepted a job in which he's able to work remotely and needs to set up his home office. Introduction. A man working on a computer in a home office. Kareem recently started a job that allows him the flexibility to work from home. Excited, but a bit overwhelmed, he realizes that he needs a reliable home office network to handle his work tasks efficiently. Let's look at the process he follows. Step 1. Choose the right hardware. Kareem starts by purchasing the essential components for his SOHO network that his company approved. A router to direct network traffic. A modem to connect to the Internet. Ethernet cables for wired connections. A network-attached storage, NAS, device for shared storage. Step 2. Connect the modem to the Internet. Kareem works with an ISP to get Internet access to his home. The ISP handles the wiring to the home and tells Kareem that his modem will connect when he attaches it to the cable outlet. Kareem unboxes his modem and follows the instructions to connect it to the cable outlet in his home. He then powers it on and waits for the lights to indicate that it's successfully connected to the Internet. Step 3. Set up the router. Next, Kareem connects his router to the modem using an Ethernet cable. He then plugs the router into an electrical outlet and powers it on. The router automatically sets some basic configuration options, which allow Kareem to connect to the router's settings interface using a browser on his laptop. Step 4. Configure the router's settings. Using his computer, Kareem logs into the router's web interface. He follows the setup wizard to configure settings like the Wi-Fi network name and password. He notes that the Wi-Fi network name is also called a Service Set Identifier, SSID, which is a new term to him. Step 5. Connect devices. Kareem wants the fastest possible connection for his work computer, so he uses an Ethernet cable to connect it directly to one of the router's LAN ports. He'll connect other devices like his laptop, mobile phone, and printer to the network wirelessly. Step 6. Set up the network-attached storage, NAS. Kareem sets up his NAS device by connecting it to the router with an Ethernet cable. The NAS device connects to a network, allowing users to store and access files from one central place. In a SOHO network, the NAS device offers Kareem a simple, scalable way to share, protect, and remotely access files from a central location without the complexity of a full server system. He then follows the NAS setup guide to create shared folders that he can access from any device on the network. Step 7. Test the network. Finally, Kareem tests his network by connecting all of his devices, both wired and wireless. He confirms that he can access the Internet, print documents, and retrieve files from the NAS. Summary. By carefully selecting and configuring each component, Kareem successfully sets up a home office network that meets his work needs. Whether it's connecting the modem and router for Internet access, setting up a wired connection for optimal speed, or adding NAS for additional functionality, each step serves a specific purpose. Now, Kareem needs to configure software for his new job so he can work from home efficiently and securely. Installing and configuring the software for a SOHO network. Workers in home offices often need to access resources located elsewhere, such as on a company server or another computer. There are various software solutions that can facilitate this remote access. Some organizations provide software packages for remote workers alongside instructions for how to install and configure them. Others ask an employee to run an application and log into the corporate network, then the organization installs and configures the software remotely. Let's explore some commonly used options and how an employee can install and configure them. Virtual Private Network, VPN, a private tunnel to the office. A VPN allows an employee to securely connect to a remote network, such as the company network, as if they were physically in the corporate office. Typical steps to configure a VPN include: download and install the VPN client software specified by the company or service provider. Open the software and enter the server details, usually provided by the company's IT department. Enter a username and password, and then connect. Remote desktop software, a computer from anywhere. Remote desktop software lets IT support technicians use their local computer to access and control another computer as if they were sitting right in front of it. This allows them to troubleshoot issues remotely. Many corporations also have cloud-based computers or dedicated office computers that remote workers can use from remote locations. Typical steps to configure remote desktop software include: install company-provided remote desktop software on the computer that the employee will use to connect. Install company-provided remote desktop software on the remote computer the employee will access. Set up a unique ID or use the employee's computer IP address to identify it as an authorized computer. Open the software on the connecting computer, enter the unique ID or IP address, and then connect. Cloud storage services, company files, anywhere and anytime. Some companies use public cloud storage services like Google Drive or Dropbox to enable employees to access files from any device with internet connectivity. Other companies host their own private cloud and files inside their firewall for added control and security. Typical steps to configure cloud storage services include: create an account with the cloud service provider or log on to the corporate network with employee credentials. Browse to a link that hosts the cloud software. Corporations typically provide these links for easy access. Install the cloud storage software on a mobile or desktop device. Drag and drop files into the cloud storage folder to make them accessible from anywhere. Firewall software, protecting remote connections. Firewall software helps secure employee devices when connecting to remote networks. Typical steps to configure firewall software include: install firewall software provided by the company. These usually will be available from a link the company provides. Open the software and configure settings to allow or restrict incoming and outgoing traffic. Companies typically will provide the configuration options or set them remotely to ensure maximum safety. Remote work often requires various software components to enable secure and efficient access to resources. This software, paired with the right hardware, can make remote working secure and efficient. Analytical thinking. In this activity, you'll apply what you just learned about how to install and configure a SOHO network by placing the steps in sequential order. Imagine you're the IT support technician for a growing small company. You need to set up a SOHO network at a new regional office. Before you begin setting up the network, your manager asks you to review the steps for installing and configuring hardware for a SOHO network. You've learned the steps to install and configure the hardware components and software for a SOHO network. Another critical step in this process is to secure the network. For many corporations, security is a top priority. Ensuring that corporate data transmits securely between a remote office and the corporate data centers requires special attention. Next, let's explore ways companies and employees can keep a SOHO network secure. Securing a SOHO network. Security is paramount when setting up a SOHO network, especially if employees are connecting to a corporate office. A compromised network can lead to data breaches, loss of sensitive information, and even financial damage. In this lesson, you'll learn how to fortify a SOHO network using both hardware and software measures. A shield with a lock surrounded by a server, a monitor, a mobile phone, a table, and a laptop computer. Securing a SOHO network with hardware. There are two primary hardware options to secure a SOHO network: using a firewall appliance and using a virtual LAN. Firewall appliance. Going beyond the software firewall on a device, a dedicated firewall appliance provides an additional layer of security. It acts as a security guard for a SOHO network, monitoring incoming and outgoing data traffic. By establishing rules that permit or deny specific types of internet traffic, the appliance acts as an essential layer of protection against unauthorized access and potential cyber threats. This helps to secure sensitive information. Typical steps to configure a firewall appliance include: connect the appliance to the network, usually by plugging it in between the modem and the router. Access the web interface for the appliance using a web browser. Use the IP address and login credentials that the user manual provides. Update the appliance firmware to ensure it has the latest security features. Configure basic settings, such as network name and password. Set up rules for allowing or blocking specific types of internet traffic based on needs and security concerns. Test the configuration to make sure it's working as intended. Monitor and adjust settings periodically to maintain optimal security. Virtual LAN, VLAN. This hardware feature is available in advanced routers to separate network traffic into different channels, thus isolating sensitive data. A virtual local area network, VLAN, functions like separate lanes on a highway, directing network traffic into distinct, isolated pathways within a SOHO network. By segregating devices into different VLANs, the network can limit who has access to what, enhancing security. For example, guest devices can use one VLAN with limited access, while more trusted devices, like work computers, occupy another VLAN with broader access. This structure minimizes the risk of unauthorized users gaining access to sensitive data. Typical steps to configure a VLAN include: log into the web interface for the router using a web browser. Enter the IP address and login credentials that the user manual provides. Navigate to the VLAN settings section, often found under Advanced Settings or Network Settings. Create a new VLAN by assigning it a unique identifier, ID, and name. Add devices to the newly created VLAN by specifying their MAC addresses or IP addresses. Define access rules for the VLAN to specify what network resources this group can or cannot access. Save the configuration and restart the router to apply the changes. Test the setup to confirm that the VLAN is segregating traffic as intended. IT support. An IT support technician needs to be skilled in setting up and managing firewall appliances and VLANs to secure a SOHO network. For firewalls, technicians might configure network parameters, apply firmware updates, and establish traffic rules, ensuring the network's protection against external threats. For VLANs, technicians might segment network traffic using router settings, controlling access, and safeguarding sensitive data by assigning specific devices to appropriate VLANs. An IT support technician might also monitor and test both hardware types to maintain robust security and troubleshoot any potential vulnerabilities. Securing a SOHO network with software. There are two primary software options to secure a SOHO network: using antivirus software and using a VPN for corporate connections. Antivirus software. Antivirus software scans programs and files for malware and blocks malicious activities. Antivirus software acts as a vigilant security guard for computers in a SOHO network. Popular applications such as McAfee, Norton, and Average help to identify and remove threats like viruses and spyware. For employees connecting to a corporate network from a SOHO setup, antivirus software adds an extra layer of defense. It guards against malware that could potentially infiltrate and compromise not just the local computer but also the larger corporate infrastructure. This makes antivirus software a key tool for maintaining the integrity and confidentiality of both personal and business data. Typical steps to configure antivirus software include: download and install the antivirus application from a trusted source. Many corporations will provide antivirus software for remote workers to use on their devices, and IT support professionals manage this software for users and corporations. Run the software and update the virus definitions database to ensure the software recognizes the latest threats. Run an initial full system scan to check for existing malware and remove it if found. Configure settings such as real-time scanning, scheduled scans, and threat notifications according to preferences and needs. Set up firewall rules within the antivirus software, if available, to control incoming and outgoing network traffic. VPN for corporate connections. A VPN for corporations operates like a secure tunnel for data traveling over the Internet in a SOHO network. By encrypting data, it ensures that private information remains confidential and safe from prying eyes during its journey between the employee's device and the destination server. This is particularly beneficial for remote workers connected to a SOHO network who need secure access to corporate resources. Popular VPN services like NordVPN, ExpressVPN, and CyberGhost add this layer of protection. They make it harder for unauthorized users to intercept sensitive data. Typical steps to configure a VPN include: obtain the VPN installation package and configuration details from the corporate IT department. IT support technicians generally are responsible for providing this software. Install the corporate VPN software on the devices that will connect to the corporate network. Launch the VPN application and enter the login credentials that the corporate IT department provides. Configure any additional settings as instructed, such as selecting a specific server or setting up multi-factor authentication. Activate the VPN connection, usually by clicking a Connect button within the application. Confirm the connection is secure and operational, often through a status indicator within the VPN application or by following verification steps provided by the IT department. Test the VPN connection by accessing corporate resources like internal websites or file servers to ensure it's working as intended. IT support. An IT support technician is generally responsible for providing, installing, and troubleshooting antivirus and VPN software. For antivirus software, they might also configure robust antivirus software and run scans to preemptively remediate malware. Additionally, for corporate VPN software, technicians might adjust settings for secure connections and validate the setup to confirm that sensitive data remains encrypted and inaccessible to unauthorized parties. Securing a SOHO network with security protocols. Using security protocols is another way to secure a SOHO network. WPA3 encryption. Wi-Fi Protected Access 3, WPA3, is the latest wireless encryption standard that Wi-Fi networks should use. WPA3 encryption functions as a high-security lock for a SOHO wireless network. It makes it more challenging for unauthorized users to gain access. By using advanced encryption techniques, WPA3 ensures that the data transmitted between devices and the router remains confidential and secure. For businesses and individuals alike, upgrading to a WPA3-enabled router provides an enhanced layer of protection for sensitive information. Typical steps to configure WPA3 encryption include: ensure the router and devices connected to the network are WPA3 compatible. Log into the web interface for the router using a web browser. Enter the IP address and login credentials that the user manual provides. Navigate to the wireless settings or security settings section. Select the option for Wi-Fi Protected Access 3, WPA3, from the encryption methods list. Set a strong passphrase for the network, adhering to recommended security guidelines. Save the settings and restart the router to apply the changes. Reconnect devices to the network, confirming that they are using WPA3 encryption when prompted for the passphrase. Multi-factor authentication, MFA. Multi-factor authentication, MFA, adds an additional layer of security when accessing sensitive resources. MFA works like a series of security checkpoints in an airport, requiring employees to present multiple forms of identification before gaining access to a network or system. In a SOHO environment, MFA enhances security by requiring not just a password, but also an additional form of verification such as a text message code or a fingerprint. Using MFA makes it significantly more challenging for unauthorized users to gain access to a network. It adds an extra layer of protection for sensitive data. Typical steps to configure MFA include: log into the account or system where MFA needs to be enabled, often through a web interface or application. Navigate to the Security Settings or Account Settings section and select the option to enable Multi-Factor Authentication or MFA. Choose the secondary verification method, such as receiving a text message code, using an authentication app, or utilizing a biometric option like a fingerprint. Follow the prompts to set up the chosen verification method, which often includes entering a code or scanning a QR code. Test the MFA setup by logging out and logging back in, completing both primary and secondary verification steps. IT support. In a SOHO network, implementing WPA3 encryption and multi-factor authentication, MFA, significantly fortifies security measures. IT support technicians must ensure that routers and devices connected to the network are WPA3 compatible, activate WPA3 via the router's settings, and establish a strong passphrase. For MFA, IT support technicians are responsible for enabling the feature through user account settings and testing the system to validate that the additional authentication layer is operational. IT support technicians might also train employees on MFA. Securing a SOHO network with routine maintenance. Routine maintenance is another important aspect for securing a SOHO network. Firmware updates. Manufacturers often release updates that fix security vulnerabilities in networking hardware. Firmware updates serve as tune-ups for the software that runs a router, computer, or other devices in a SOHO network. These updates often include fixes for security vulnerabilities, like patching holes in a fortress wall to keep invaders out. By regularly updating the firmware of routers and devices, a SOHO network maintains its defenses against new and evolving cybersecurity threats. This helps to secure sensitive data and ensure the overall integrity of the network. Typical steps to configure firmware include: log into the web interface for the router using a web browser. Enter the IP address of the router and the login credentials. Navigate to the section labeled something like Firmware Update, usually under Advanced Settings or System Tools. Check for available updates and download the latest firmware version, following on-screen instructions. Install the update. Reboot the router to complete the update process. Confirm the update was successful, often indicated by a version number or status message in the interface. Monitor network traffic. Monitoring network traffic in a SOHO network is akin to having a security camera at the entrance of a building, recording who comes in and goes out. It involves tracking the flow of data between devices and the Internet to identify any unusual or suspicious activity. By consistently keeping an eye on network traffic, it becomes easier to spot unauthorized access or potential threats, such as malware or hacker attempts. This proactive approach helps to fortify the network's defenses, ensuring the security of sensitive data and resources. Typical steps to configure network monitoring include: choose a network monitoring tool compatible with the SOHO network, such as Wireshark or PRTG Network Monitor. In some cases, a networking system will have a proprietary network monitoring tool. Install the chosen software on a computer that is on the network. Launch the network monitoring application and navigate to the Settings or Configuration menu. Set up alerts or thresholds for unusual activities like high bandwidth usage or unauthorized access attempts. Start the monitoring process. IT support. In securing a SOHO network, IT support technicians might be responsible for managing both firmware updates and network traffic monitoring. They might routinely update firmware in the router's settings, thereby closing security gaps. Also, they might install, configure, and use network monitoring tools. Securing a SOHO network involves a multi-layered approach, incorporating both hardware and software solutions. From setting up a dedicated firewall appliance to using advanced encryption methods, each step adds another layer of protection. And when connecting to a corporate office, additional measures like using a corporate VPN and enabling MFA can help the connection to remain secure. Identifying common issues in a SOHO network. In the interconnected world of a SOHO network, maintaining a stable and secure environment is crucial for smooth operations. Much like a garden requires regular upkeep to prevent weeds from overtaking it, a SOHO network needs ongoing attention to address common issues that can disrupt its functionality. Identifying these problems is the first crucial step in fostering a healthy network. The IT support technician's role often encompasses both the detection of network issues and the resolution of technical challenges encountered by employees. In smaller organizations, IT support technicians often execute a range of responsibilities, from managing security protocols to providing timely support for connectivity problems. Their focus is to maintain network security, provide effective troubleshooting, and ensure that the network operates reliably. In larger organizations, IT support technicians might help remote employees with issues on the employee's SOHO network. Two women working on their laptops at a desk and putting their fists together while smiling. Select each card to learn more about common issues in a SOHO network. Slow internet connection. One of the most frequent complaints is slow internet speed, affecting productivity and user experience. This can result from a range of factors, such as outdated hardware, too many connected devices, or even issues with the internet service provider. Wi-Fi signal drops or weak coverage. Areas in the office or home can experience poor Wi-Fi signal, akin to having dead zones in mobile coverage. This often necessitates network extenders or adjustments in router placement. Device connectivity issues. Devices like printers, smartphones, or laptops can sometimes struggle to connect to the network. This might be due to incorrect settings, outdated drivers, or compatibility issues. Unauthorized access. Security is paramount, and unauthorized access to the network poses a significant risk. This issue can manifest as unknown devices connected to the network or unusual data traffic patterns. Frequent disconnections. A network that keeps disconnecting can disrupt work or important tasks. Causes might include hardware malfunctions, software issues, or even service interruptions from the provider. Inability to access network resources. Difficulty in accessing shared files or hardware resources like printers is another common issue. This can result from incorrect permissions, misconfigured settings, or network segregation. Software conflicts. Sometimes, antivirus programs or firewalls can interfere with network connectivity, behaving like overzealous security guards that keep out even legitimate traffic. By proactively identifying these prevalent issues in a SOHO network, IT support technicians can take targeted measures to resolve them. This not only helps in minimizing downtime but also contributes to creating a more secure and efficient networking environment. A well-maintained network, much like a well-tended garden, will yield better performance, security, and peace of mind. Summary and looking ahead. In this lesson, you learned about small office/home office, SOHO, network components. You stepped through the processes and techniques to install, configure, and secure SOHO networks. And you got an overview of typical issues individuals experience when using a SOHO network. The next lesson covers different types of network management software to keep networks secure and running smoothly. About this lesson, network management software. In this lesson, you'll learn about the software IT support technicians use to monitor and manage networks. You'll learn about the features that such software can provide and how to use it to manage a corporate and SOHO network. Scenario: using network management software. Modern networks are the backbone that support everything from national economies to personal communication. While digital networks today are much more resilient and self-maintaining than they were in the early days of their development, they have also gotten much more complex. This complexity means the networks need skilled technicians to help keep them running at their best. Thankfully, as networking has advanced, so has the software that technicians use to manage them. Network management software is an important tool that IT support technicians use daily. A man in a wheelchair at a desk with 6 monitors displaying graphs and charts. Explore this short scenario to learn about how an IT support technician uses network management software to help keep her company's network running smoothly. Introduction. Woman sitting at a desk with a desktop and laptop computer, taking notes. Jenny, an IT support technician, starts her day by logging into the network management software to check the health of the corporate network she oversees. The software dashboard gives her a quick overview, highlighting any areas that might need her attention. Let's explore how Jenny uses network management software to help keep her company's network running smoothly. 1. Device discovery and mapping. Jenny first checks the device map on her screen. She notices a new device showing on the network. She verifies that it's a legitimate addition, a new printer in the marketing department, and updates the device's information in the management software. 2. Performance monitoring. Next, she examines the performance metrics. These show the activity and performance on the network. She sees delays occurring in the research and development section of the network. After some investigation, she finds that these delays, or latencies, are due to a large data transfer happening. She uses the management software to adjust the network settings to accommodate the spike in demand. 3. Security management. Jenny then reviews the security alerts. She sees that an unauthorized login attempt happened overnight. The software had already automatically blocked the IP address, but she investigates further to ensure there are no vulnerabilities. 4. Backup and recovery. Jenny checks the backup section of the software and confirms that the nightly data backup was successful. She tests the recovery process with a small file to make sure she can restore it in case of a real failure. 5. Automated alerts and reporting. Jenny sets up automated alerts for critical issues such as security breaches and performance drops. She also schedules the software to generate weekly reports, which she'll review to look for any long-term trends or issues. 6. User management and access control. Jenny notices that an employee from the sales department is trying to access a restricted file. She checks the user's role and sees they shouldn't have access to it. She updates the access controls to prevent future unauthorized access. 7. Patch and update management. Before ending her day, Jenny sees notifications for software updates and security patches. She schedules them to install after office hours to avoid disrupting regular work. 8. Bandwidth optimization. Lastly, she reviews bandwidth usage. She sees that the video conferencing tool is using a lot of bandwidth, affecting other services. She prioritizes it lower during non-meeting hours to better balance the network resources. Summary. Jenny logs off, satisfied that the network is running smoothly and securely. With the help of network management software, she effectively manages various aspects of the network, ensuring optimal performance and robust security for her organization. Jenny uses network management software to help her manage things like security and performance, as well as allow only specific users to access the network. She uses this software to map the network and optimize it for peak performance. To better understand the role this software plays in network management, let's examine the features of each of the network management tools Jenny uses. Features of network management software. In a corporate network, network management software plays an essential role in maintaining a smooth and secure operational environment. This software comes with various features and capabilities focused on simplifying network management tasks. A man looking at a monitor with web browsers, an alert, security shield, and stopwatch. Select each section to learn more about common features of network management software. Device discovery and mapping. Network management software identifies all devices on the network and creates a visual map. This visual representation helps in understanding the network's layout and identifying any potential weak points. Performance monitoring. The network management software continuously measures critical metrics such as speed, bandwidth usage, and latency to monitor the network's overall performance. This helps in identifying areas that might need improvement or troubleshooting. Security management. Security is a significant aspect of network management. Network management software often works in conjunction with firewalls and antivirus programs to provide a comprehensive security solution that protects against unauthorized access and various cyber threats. Backup and recovery. Network management software usually includes options for backing up data and recovering it in the event of a system failure. This ensures that organizations can quickly restore important data if needed. Automated alerts and reporting. The network management software can send real-time alerts for anomalies or security breaches, enabling IT support technicians to take immediate action. It can also generate detailed reports for analysis and compliance purposes. User management and access control. One feature of network management software is the ability to manage user access based on roles. This ensures that employees have access only to the network resources they need, Enhancing security. Patch and update management. Keeping network management software up to date is crucial for network security and performance. The network management software automates this task by ensuring that all devices on the network are running the latest versions of software and security patches. Bandwidth optimization. The network management software efficiently allocates network resources to ensure that important business applications have the bandwidth they require. Activity. Identify uses and features of network management software. Employability skills. Critical thinking. In this activity, you will review a collection of IT support scenarios and choose the card that matches the correct use or feature of network management software. Scenario 1. Arjun receives a dashboard alert indicating multiple failed login attempts for an administrator account. The attempts were made in quick succession, raising concerns about a potential breach in the network. He reviews the logs to investigate the source and nature of these failed login attempts. Which feature of network management software should Arjun use to protect against unauthorized access? Scenario 2. Margaret finds that the network's overall speed has slowed down significantly. After digging into the issue, she discovers that a large video conference is monopolizing most of the network's available resources, affecting other essential services. Which feature should Margaret use to adjust the settings to ensure that the network's resources are allocated more evenly, allowing all services to operate efficiently? Scenario 3. Paolo needs to get information about the network for the executive team so they can prepare a budget for improvements, upgrades, and maintenance. They are requesting information about critical metrics such as speed, bandwidth usage, and latency. Which feature of network management software should Paolo use to see the activity and identify areas of the network that might need improvement? Scenario 4. While scanning her dashboard, Consula notices that an employee, who is listed as a sales associate, is attempting to download sensitive files from the financial department. Consula confirms the employee's role doesn't authorize him to view these files. Which feature of network management software can Consula use to ensure that the employee only has access to the network resources he needs? Well done! You're getting familiar with real-world scenarios that illustrate how IT support technicians rely on different features of network management software. Next, learn about how small office/home office networks can differ from large corporate networks. The software needs of corporate versus SOHO networks. SOHO networks have specific needs that differ from those of large corporate networks. The main differences lie in the scale, complexity, and intended purpose of the network. Let's explore the differences between corporate networks and SOHO networks in terms of their needs and considerations for network management software. Select each card in the following sections to compare corporate networks and SOHO networks. Scale and complexity. Corporate networks. Corporate networks can host hundreds or even thousands of devices. For corporate networks, a wide array of advanced options and controls that cater to specific business needs might be prioritized even if these options make the system more complicated to use. SOHO networks. SOHO networks are usually much smaller in scale and less complex than corporate networks. They can consist of only a handful of computers and devices, so simplicity and user-friendliness are prioritized, allowing for easy management and maintenance without the need for specialized IT expertise. Budget constraints. Corporate networks. While cost is typically a factor for corporate network management, it has less of an impact on decision-makers when choosing network management software. Keeping the business network operating well generally takes priority for companies. SOHO networks. Cost is often a significant concern for SOHO environments. Therefore, network management software suitable for these networks is usually less expensive and might even offer free versions containing just the essential features. User expertise. Corporate networks. Network administrators and IT support technicians who have special training on network management software tend to manage corporate networks. Businesses can usually ensure their technicians can take the time to learn and master the software before relying on them to manage the network. SOHO networks. Individuals who might not have specialized networking expertise often manage SOHO networks. Network management software for SOHO usually aims to be user-friendly, with intuitive interfaces and straightforward setup procedures. Security requirements. Corporate networks. While security is essential for any network, a corporate network often needs advanced security features like intrusion detection systems, which might be excessive for a typical SOHO network. SOHO networks. Simpler security measures, such as basic firewall and antivirus integrations, are often sufficient for SOHO environments. Remote access. Corporate networks. Corporate networks can have more controlled environments and might restrict remote access to specific roles or departments. However, corporate networks do need to manage remote access scenarios, so corporate network management software would focus on this aspect of the scenario. SOHO networks. SOHO networks often require robust remote access capabilities to allow for work from home or remote office situations. Reporting and alerts. Corporate networks. Corporate networks usually require detailed reporting for compliance and performance tracking. SOHO networks. Generally, SOHO networks need a minimal level of reporting and alerts. Scalability. Corporate networks. Corporate networks often require software that can enable technicians to scale the network quickly to accommodate growth. SOHO networks. Network size tends to remain relatively stable in SOHO settings. So, scalability is generally less of a concern. Network management software for SOHO environments prioritizes ease of use, affordability, and basic security features. In contrast, corporate network management software focuses on extensive feature sets, advanced security, and scalability. Understanding these differences can help individuals choose the appropriate software for their specific networking needs. Scenario: using management software in a SOHO environment. Users and IT support technicians alike can use network management software to keep a SOHO network running well and ensure it's ready to connect to a corporate network if needed. Let's explore how network management software enhances the performance and efficiency of a SOHO network using a scenario. Imagine the software is a new hire employee at a small office. It's the software's first day on the job, and it must perform a range of tasks to do its job. The software's name is Nemesis. A woman sitting at a desk using her mouse and running a computer program, which has a robot face with a talk bubble on the computer monitor. A day on the job for network management software. There is a mix of anticipation and skepticism in the atmosphere on Nemesis' first day. After all, Nemesis isn't just any new hire, it is specialized network management software trusted with keeping the SOHO network both efficient and secure. Karen, the office's IT support technician, completes the software's installation and watches as Nemesis springs into action. Immediately, Nemesis starts its initial assessment, scanning the entire network. It quickly identifies each connected device, workstations, printers, smartphones, and so on, and creates a visual map. This will be the foundation upon which all future actions will be based. A radar scanner displaying different devices around in a circle, including a printer and computer monitors. Next on the agenda is establishing a secure connection to the corporate network. Karen uses Nemesis to configure a virtual private network, VPN, ensuring that all data traveling to and from the corporate headquarters is encrypted and secure. She double-checks the firewall settings and makes sure the antivirus definitions are up to date. A quick test run confirms the secure tunnel is operational. A computer monitor displaying a security lock and a badge with a magnifying glass and clipboard next to it. Throughout the day, Nemesis keeps a vigilant eye on network performance. It monitors real-time metrics and watches for any signs of slow speeds or downtime. At one point, it detects a spike in network usage that is affecting performance. Like a skilled detective, Nemesis traces the issue back to a non-essential application running on one of the workstations. It sends an immediate alert to Karen, recommending that she limit or disable the application during work hours. A website displaying a magnifying glass over an alert, represented by a red triangle with an exclamation point. Security is always a priority, so NEMIS ensures that multi-factor authentication, MFA, is enabled, particularly for devices accessing sensitive corporate data. When an attempt to connect to the network from an unrecognized device is made, NEMIS immediately sends a verification code to Karen's phone. Only upon entering the correct code is the device granted access. By late afternoon, NEMIS has received alerts for available firmware updates for the office router. It informs Karen and schedules the updates to run after business hours to avoid any interruptions. This might seem like a minor task, but NEMIS knows that outdated firmware is like an open invitation to security risks. A mobile phone connecting to a message bubble on a computer monitor. Even as the office empties out, NEMIS's day is far from over. The software switches to its after-hours mode, running a comprehensive performance and security report for the day. It emails this to Karen for her morning review. NEMIS stays alert throughout the night, ready to detect any security issues that arise, and preparing for another day of ensuring that the network remains a secure and efficient asset for the office. A robot face with a chat bubble displaying on the computer monitor. NEMIS, or Network Management Software, isn't just a tool but an integral part of the team, seamlessly ensuring the SOHO network remains as reliable and secure as the people it serves. How management software connects SOHOs to corporate networks. Managing a SOHO network requires attention to detail and proactive steps, especially if the network connects to a larger corporate infrastructure. What happens if the SOHO network needs to connect to a company network? The network management software serves as the central hub for overseeing this. It simplifies many of the complex aspects into a more user-friendly experience for IT support technicians and network administrators. Let's explore how management software connects SOHO networks to corporate networks and makes network management more simple for IT support technicians and network administrators. How does initial setup and device mapping work? The software scans and identifies all connected devices to provide a visual network overview. How does the SOHO network connect to a corporate network? The software assists in establishing a secure VPN to encrypt data and secure the connection between SOHO and corporate networks. What does performance monitoring entail? The software continuously monitors for issues like slow speeds or downtime and provides solutions or alerts for any detected problems. What security measures are included? Network management software typically incorporates basic firewall and antivirus features. IT support technicians can add further layers of security for connections to a corporate network, such as MFA, to validate user identities. How are updates and patches managed? The software alerts users to available updates or patches, which are crucial for security enhancements and should be applied promptly. How does remote monitoring and control work? The software enables network management from remote locations, which is particularly beneficial for SOHO networks operating as part of a larger corporate entity. What is the role of reporting in network management software? The software generates performance and security reports for reviewing long-term trends, essential for maintaining an efficient and secure SOHO network. Summary and looking ahead. In this lesson, you learned that network management software is a valuable tool for IT support technicians to keep networks running at their best. You reviewed several real-life scenarios to select the network software management feature to utilize. You also learned how the software performs on a daily basis and the different needs for this software for corporate networks compared to SOHO networks. The next lesson covers how IT support technicians can use different types of software to enable users to access data and work on central computers from remote locations. About this lesson, remote access methods. In this lesson, you'll learn the essentials of secure remote access. From setting up VPNs and using remote desktop protocol for remote work to transferring files with FTP and controlling remote computers with Telnet, you'll learn to navigate and secure digital communications effectively. The purpose and function of a virtual private network, VPN. A woman using a laptop computer with VPN on the screen. A VPN is like a secure tunnel that helps keep information safe while it travels over the internet. Imagine it as a secret tunnel that only the sender and receiver know about. This tunnel is encrypted, meaning the information inside is scrambled and can only be read by the intended parties. By creating a secure tunnel, a VPN safeguards data as it travels over the Internet. It does this by using special ports, protocols, and services. Ports. Think of ports like different doors in a house. Each port has a specific number, and it allows information to go in and out of a computer. When you send an email or visit a website, you're using one of these doors to communicate. When someone turns on a VPN, it wraps the data in a secure cover and sends it through one of these numbered doors. This makes sure that the information stays private and reaches the right place. By using these designated doors, the VPN keeps the data safe and helps it get to its destination without any issues. Protocols. Protocols are like special languages that computers speak to understand each other. They're the set of rules that guide how to send and receive information. Just like people need a shared language to communicate, computers need protocols. A VPN employs various protocols to establish a secure connection between a user's device and a remote server. These protocols set the rules for how to send and receive the data. Common protocols include OpenVPN, L2TP/IPsec, PPTP. Each of these has its own set of guidelines for encryption, speed, and reliability. The protocol chosen for a specific task determines the level of security and the speed at which data moves between the device and the server. By following these specific rules or protocols, the VPN ensures that data travels securely and efficiently, helping to keep the network safe. Services. Services are the tasks that computers can perform, like sending emails, showing websites, or sharing files. Each service uses specific ports and protocols to work properly. When a VPN starts, it creates a secure tunnel for services like emails, websites, or file sharing. Although these services continue to use their specific ports and protocols, the VPN encrypts the data to ensure it's transmitted safely. Imagine sending a sealed document with a trusted courier. Even if someone intercepts the courier, they can't read the document. Similarly, a VPN keeps the tasks that your computer performs private and protected from outsiders. VPNs carefully choose which ports and protocols to use for a given service to ensure that data stays safe. This is why companies use VPNs to shield their valuable information from prying eyes. Setting up a VPN. Using a VPN is like using a private, secure tunnel for your car on a highway full of vehicles. The VPN service acts as your very own dedicated lane, keeping your journey separate and secure from others. Both remote workers and employees at an office can connect to corporations using a VPN. Let's examine how they do this. A man sitting at a desk working on a computer. Companies provide the following to employees who need to connect to their corporate network using a VPN. VPN software. This is the employee's vehicle navigation system. It helps direct data traffic through the private tunnel, ensuring it doesn't mix with the public highway. Login information. This is the employee's personalized access card to enter the tunnel. Without this, they would be stuck on the regular, crowded highway. VPN server information. Think of this as the coordinates for various private tunnel entrances and exits. It offers employees options to enter and leave the tunnel, ensuring their journey is smooth and efficient. Security protocols. These are like the guards and security checks at each tunnel entrance, ensuring that only authorized vehicles, data, can enter and no threats sneak in. Here are the general steps employees take to connect to a corporate network using a VPN. Download and install the VPN client software. The employee receives a link or access to the VPN client software from the company. They download and install this software on their device. Configure VPN settings. During this step, the employee might need to set the correct protocol. The company often predetermines the VPN protocol, like OpenVPN or L2TP. The setup process will guide employees about the protocol to select. Input the VPN server address. The company's IT department provides the specific server details. Employees enter this information into the client software. Adjust additional settings. Some companies might recommend specific configurations, such as enabling a kill switch or setting the VPN to launch at startup. Log in with user credentials. Employees enter their username and password that the company provides. The company might also implement multi-factor authentication, MFA, for an added layer of security. Choose the right server. Based on the company's guidelines, employees select the appropriate server. In companies with different locations, this might mean choosing the server corresponding to the employee's specific office or location. Maintain the connection. After establishing the connection, employees should periodically verify their VPN connection status. This ensures the secure tunnel remains active during work sessions. Log out. Once employees complete their tasks or work for the day, it's advisable for them to disconnect from the VPN to free up resources and maintain optimal network performance. Stay updated. The company often rolls out updates to the VPN software. Employees should ensure their VPN client remains up to date to benefit from enhanced security and functionality. The purpose and function of Remote Desktop Protocol, RDP. Have you ever needed files that were on a computer at your work or school, and you were unable to access them because you were working remotely? Consider the scenario with Adrian, who is in a similar situation. Files far, but near. Adrian has always taken pride in being an early riser. Today, he is especially glad for this habit because he is presenting the quarterly financial projections to his company's executive team. However, as the first light of dawn begins to pour into his room, he quickly realizes he faces a significant problem. He notices his presentation slides lack the most recent updates he made late last Friday at the office. Panicking, he remembers saving the final version on his desktop computer at work, but now he is miles away at home, and the presentation is in 2 hours. He calls the IT support line. After a brief hold, he is connected to a technician named Riley. As Adrian explains his predicament, Riley listens intently, already formulating a solution. Have you ever used Remote Desktop Protocol, Adrian? Riley inquires. No, I haven't. What's that? Adrian responds, curious. It's a tool that allows you to access your office computer remotely from your home. Riley explains. It's as if you're sitting right in front of your office computer. You can access all your files and applications just as you would if you were physically there. Relief washes over Adrian as Riley guides him through the steps of establishing the remote connection. Within minutes, Adrian is viewing his office desktop on his home laptop, and there it is, the final version of his presentation. The meeting is a resounding success, and the executives are none the wiser about Adrian's early morning crisis. Grateful, Adrian sends a thank you email to Riley, appreciating the swift resolution and introduction to the wonders of Remote Desktop Protocol. Remote Desktop Protocol, RDP. So, what is Remote Desktop Protocol, RDP? It's a secure network communications protocol developed by Microsoft. It's like a window that lets you see and control another computer. Companies use RDP because it allows traveling employees to access their work computers. It also enables administrators and IT support technicians to diagnose and repair an employee's computer. An RDP enables employees to use company tools from their home computer, even if they don't have them installed. RDP isn't the only remote access solution available. There are several other solutions, including virtual network computing, VNC, and secure shell, SSH. The following table compares these software solutions. Here is the information from the table converted into complete sentences. Remote Desktop Protocol, RDP. Pros. RDP is native to the Windows environment, making it highly compatible with Windows systems. It features a simple and intuitive interface for users. When configured correctly, it provides secure integration. Cons. It is challenging to use outside of the Windows platform. It is vulnerable to security threats if it is not properly secured, such as when it lacks strong passwords or two-factor authentication. Virtual Network Computing, VNC. Pros. VNC is platform independent and works seamlessly across various operating systems. It offers a simple and user-friendly interface. It provides flexible configuration options to suit different needs. Cons. Its security can be weaker if it is not specifically configured with encryption or strong authentication methods. Its performance can lag compared to other remote desktop methods, especially when running over slow internet connections. Secure Shell, SSH. Pros. SSH is a platform-independent protocol that works across multiple operating systems. It places a strong emphasis on security by utilizing robust encryption. It is highly lightweight and efficient in its operations. Cons. It is primarily a command line tool, which might be daunting for non-technical users. It requires a solid knowledge of commands to be used efficiently. RDP is particularly convenient for Windows environments, while VNC offers a user-friendly experience across any platform. SSH stands out for its emphasis on security and is favored for sensitive operations. While each remote solution has its strengths and can work on multiple platforms, the choice ultimately depends on a company's specific needs and preferences. Using File Transfer Protocol, FTP, to transfer files between computers. File Transfer Protocol, FTP, is a protocol that people use to send and receive files. It can move any type of file, photos, documents, videos, and so on, between computers. FTP uses a variety of security measures to ensure that files are safely sent and received. A file on the left and a server on the right, with an arrow pointing from the file to the server. In the early days of FTP, people had to use the command line to use the protocol. While all desktop operating systems support command line commands, they're not always easy to use. Here are a few examples of FTP commands you can run from a command line. To view files and folders, use the dir command to display the files and folders available on a server. To navigate to different folders, the cd command enables you to switch to a different directory, folder, on a server. For example, to move to the Documents folder, type cd user/documents. To rename files, the rename or mv commands allow you to change the name of a file. Here's how you can rename a file: rename old_file_name.txt new_file_name.txt. To upload files to a server, use the put command to upload a single file or boot for multiple files. For instance, to upload file.txt, use put file.txt. To download files from a server, use the git command to download a single file or mjit for multiple files. For example, to download file.txt, type git file.txt. To simplify the use of FTP, companies began to develop software applications to provide easy-to-use FTP interfaces. This client software still uses command line commands in the background, but it gives the user a simpler interface to work with. Some of the most common FTP clients include FileZilla, WinSCP, QtFTP, and Transmit. FileZilla is multi-platform and open source. WinSCP and QtFTP are bound to the Windows operating system, and Transmit is bound to Mac. Securing FTP connections. When you're moving files between computers, think of it like sending a letter through the mail. When you're sending a letter, you seal it and perhaps use a privacy envelope so people can't see what's inside. Similarly, there are ways to make sure your files are sealed safely when you send them, including 1. SSH File Transfer Protocol, SFTP. Imagine SFTP is like a locked box. You put your letter, or file, inside, lock it, and only the person you're sending it to has the key. This method makes sure that your file is secure from start to finish. 2. FTP Secure, FTPS. FTPS is like sending your letter in a sealed envelope. It might not be as tough as the locked box, but it still does a great job keeping prying eyes away. This method is especially good if you're working with older computer systems. Select each card to reveal best practices for keeping files safe when using FTP. Pick the best method for you. Think about what you need. Are you working with newer or older computer systems? How private is the information you're sending? Keep your software updated. Just like you'd check for holes in your envelope, make sure your computer's software doesn't have any weaknesses. Update it regularly. Use strong passwords. Make sure you pick a tough-to-guess password, like having a secret handshake. It's even better if you have a two-step process to access your files, such as MFA. Be careful who you trust. Only let people you trust access your files, just like you'd only share a personal letter with someone close to you. Keep an eye out. Check regularly to make sure no one is trying to peek at your files without permission. Protect your computer. Your personal computer is like your home mailbox. Keep it safe from viruses, and make sure it's always in good shape. What do you think? Employability skills. Analytical thinking. Can you think of reasons why an IT support technician would use the command line to send files using FTP instead of using a software package? Evaluate your thinking. Does your answer account for the following? Availability. All desktop operating systems have a command line interface, and if the IT support technician learns FTP commands on one system, they can use the same commands on any other system. Reduced learning curve. By learning FTP commands once, an IT support technician doesn't have to spend time learning how to use different software packages for the various systems they might support. Typing commands tends to be quicker in many cases than navigating a user interface, and so many technicians prefer to do work like file transfers from the command line. Activity: upload, modify, and download a file using FTP. Employability skills. Critical thinking. In this activity, you'll apply what you've learned about FTP commands by writing commands to browse to a directory, place a file on a server, rename it, and then download the file. You recently started as an IT support technician at a new company. One of your first tasks is to upload a support document to the company's FTP server and change the name of the document to reflect the new version. You'll then download it from the server so you have a copy on your local computer. Using Telnet to remotely access and control a computer. Imagine a time before the advanced video calls and instant messaging that people use today. Picture a simple telephone call, clear, direct, but not always private. In the digital world, Telnet functions much like that phone call. It's a tool that allows one computer to call another over a network. By using Telnet, users can give commands to and receive responses from distant machines. Like the open nature of a telephone conversation, Telnet transmits data in plain text. This means when a person sends a message or a command, it's like speaking openly in a language everyone can understand. Headphones with a microphone attachment with two chat bubbles and a question mark. While this straightforwardness has its advantages, such as ease of use and compatibility with older systems, it also has its pitfalls. Just as someone might overhear a phone conversation, in the digital realm, prying eyes can intercept unencrypted data. This makes it crucial to be cautious about the kind of information shared over Telnet, especially as it lacks the protective measures that newer communication tools offer. Historically, Telnet was a go-to tool for many professionals needing direct interaction with remote systems. While more secure alternatives have emerged over the years, Telnet remains invaluable for certain tasks. IT support technicians might use Telnet to interact with older systems, a skill that's important for managing and resolving issues with older infrastructure, as needed. This proficiency is essential for maintaining the network's performance and reliability, especially when dealing with older, legacy systems that might not support newer technologies. In essence, Telnet is like a trusty old telephone in a world of smartphones. It might not have all the fancy features, but it gets the job done, especially when reaching out to legacy systems. Common Telnet tasks. Because Telnet is a versatile protocol, it can perform various tasks remotely. Network engineers, administrators, and IT support technicians use Telnet for different tasks. Let's explore some of these common tasks and who might perform them. Configuring network devices. Network administrators and IT support technicians use Telnet to configure devices like routers and firewalls. They can set up IP addresses, adjust security settings, and more. Example command. To start a Telnet session, type Telnet device IP address. Upon connection, use commands like set IP address desired IP address to configure the device. Running scripts. With Telnet, network engineers and network administrators can execute scripts that streamline the configuration of routers and switches, making the process consistent and less error-prone. Example command. After initiating a Telnet session, engineers can use load script_name.txt. This command runs predefined commands in the named script file. Checking open ports. Telnet assists network administrators in identifying open ports on remote systems, ensuring network security by highlighting potential vulnerabilities. Example command. Telnet hostname/IP address port number. If the port is open, Telnet establishes a connection; if not, it returns an error. Remotely accessing legacy systems. For older or specialized systems that depend on Telnet, network administrators and IT support technicians can access and manage them efficiently. Example command. Telnet legacy system IP address. Once connected, use standard navigation commands on the system. Transferring files using the Trivial File Transfer Protocol, TFTP. Network engineers, administrators, and IT support technicians can use the Trivial File Transfer Protocol, TFTP, to transfer files in situations needing a straightforward file transfer approach. TFTP is a simpler version of FTP. Example command. First, initiate the TFTP server using TFTP server IP address. Then, to get or put files, type get file name, put file name. The versatility of Telnet makes it a useful tool to perform a variety of tasks. However, due to the lack of encryption and security, it is not recommended for sensitive operations. But, understanding its capabilities can enable users to leverage Telnet in their network environments and improve workflow. Summary and looking ahead. In this lesson, you learned about VPNs and the key components of a VPN. You learned about the process of setting up and using a VPN to securely connect to a corporate network. You learned about the differences between Remote Desktop Protocol, RDP, and other remote access technologies. You practiced use basic FTP commands, and you explored best practices for securing FTP connections. You also learned about basic Telnet commands to remotely access a computer. You've completed the final lesson of this module. Next, you'll review the module's key points and explore additional resources related to network troubleshooting, security, and management. Points to remember. Key concepts. 1. Network troubleshooting tools like ping, traceroute, and IP protocol configuration help identify and diagnose issues on networks. 2. Command line interfaces provide access to essential network troubleshooting tools. 3. Tools like network mappers, router interfaces, and monitoring protocols help configure, secure, and maintain wired networks. 4. Tools like Wi-Fi analyzers, packet sniffers, and router interfaces help configure, troubleshoot, and secure wireless networks. 5. Common Internet connection types include cable, fiber optic, satellite, and mobile networks, each with different speed and availability. 6. Network types like LANs, WLANs, WANs, and mobile networks have distinct features and are suited to specific use cases. 7. SOHO networks have essential components like routers, modems, cables, switches, and extenders to enable connectivity. 8. Proper installation and configuration steps ensure SOHO hardware components work together smoothly. 9. Software solutions like VPN, remote desktop, and cloud storage enable remote workers to access resources securely. 10. Hardware, software, protocols, and routine maintenance all play a role in securing SOHO networks. 11. Network management software aids monitoring, troubleshooting, and optimization of corporate and SOHO networks. 12. Network management software provides centralized control through features like mapping, monitoring, security, backup, alerts, reporting, and user management. 13. SOHO networks need more basic, user-friendly, and affordable network management software compared to corporate networks. 14. VPNs provide secure remote access by encrypting data through tunnels using designated ports, protocols, and services. 15. Remote Desktop Protocol, RDP, allows remote control of a computer for file access, compared to VNC and SSH. 16. FTP moves files between computers using basic commands. FTPS and SFTP improve security. 17. Telnet enables tasks like configuring network devices and transferring files by directly accessing remote systems. Big ideas. In addition, you explored or practiced these skills. Employability skills. Critical thinking. Categorize network troubleshooting tools and explain how to use them to diagnose issues. Explain how to use command line commands to diagnose network issues. Apply knowledge of network components to put the installation steps in the correct order. Select network management software features for real-world scenarios. Describe the process to install and configure hardware for a SOHO network. Identify network monitoring tools that an IT support technician uses to monitor network health, performance, and security. Analytical thinking. Differentiate between internet connection types and network types for various scenarios. Evaluate the suitability of internet connection and network types for different use cases. Differentiate between the needs for network management software for corporate and SOHO environments. Determine which IP address management tool allows technicians to view and change device IP configurations. Type basic FTP commands to upload, modify, and download a file. Identify the remote access technology best suited for a given situation. Learning objectives. Now that you've completed this module, you should be able to determine troubleshooting tools and apply best practices to manage and maintain a network for a scenario. Select the type of network based on a scenario about the internet connection and network features. Explain the process to install and configure hardware and software for a small office/home office, SOHO, network and keep it secure. Conclude network management software features to monitor, manage, and secure a SOHO network. Differentiate between remote access technologies and explain how to securely access and transfer files using them. Write commands to upload, modify, and download a file on an FTP server. Explore more resources. To explore concepts covered in this module in more depth, check out these resources. What is networking? Opens in a new tab. This is an overview by IBM of computer networking. It explains key concepts like IP addresses, nodes, routers, switches, ports, and network cable types, different network architectures and topologies, and highlights the importance of network security. What is network troubleshooting? Opens in a new tab. This resource by network leader Cisco is about the role of network troubleshooting in maintaining business resilience and the various steps and tools involved in diagnosing and resolving network issues. Best practices for keeping your home network secure, opens in a new tab. This resource by the United States Department of Defense provides comprehensive guidelines on securing personal computing devices, network devices, and home entertainment devices, as well as safe internet behavior. What is network management? Opens in a new tab. This IBM resource provides an overview of network management, including the tasks involved, the use of a centralized system for real-time data collection and control, the protocols for managing and maintaining the network, and the benefits.